Today we're going to be talking about convergent plate boundaries. That's right. Now, a convergent plate boundary is when two separate plates go into each other. They push into each other. And an example of this that we have IRL in real life is the Andes Mountains, which you can find here when the Nazca plate and the South American plate push together. And that causes the land, the crust, and the other parts of the layers of the earth, they push together and they form mountains. Alright, and moving on, we are talking about divergent plate boundaries. That's kind of like the opposite of convergent, where the plates go away from each other, as shown in the arrows on our globe. And for our real life example here, we have the Pacific plate and the Philippine plate going away from each other, and this creates the deepest trench in the whole world. Do you guys know it? I'll give you 5 seconds to guess. That's right, the Mariana Trench. Now, some other types of ecological events that occur are seafloor spread, volcanoes, and of course trenches. Thank you. And the last plate boundary we are talking about today is the transform plate boundary. Now, for a transform plate boundary, that is when two plates slide against each other. One's going one way, the other is going another, and they're sliding against each other, almost like two pieces of sandpaper getting like that. Now, real life example, the San Andreas Fault. It's right along the border of California, where the Pacific plate is going south and the North American plate is going northward. And this is the site of a lot of earthquakes and fault lines, and that's because these plates, they aren't perfectly smooth. They have a lot of ridges, and those ridges push against each other and they crack, and that causes a lot of seismic activity, causing earthquakes. Alright, we are talking about Hadley cells. Hadley cells on both sides of the equator, or ITCZ right here, and they go from the center of it to around 30 degrees on both sides. So Tropic of Cancer up here and the Tropic of Capricorn down here, and they move in counterclockwise motions and clockwise motions on that side. And this is because the Hadley cells, they're in the troposphere, so that heat rises up and then it helps kind of move that air around, because that hot air and cold air twist around each other. Alright, you might be asking yourself, how does this hot air get to the Hadley cells? Well, that's a great question. Solar energy, that's the thing that heats up the earth, right? So that solar energy causes that warm air to rise up into the troposphere, where it can interact with the Hadley cells. Now, these convection occur due to Earth's heat. Where does that heat come from? It usually stems from magma beneath the Earth's crust. This region, it also has intense pressure and density, and this creates an incentive for all these molecules to create these currents. Alright, and this leads us to the question, what are some biomes that are created as a result of these Hadley cells and convection cells as a whole? Well, there are two major ones. First off is deserts, like the Sahara that is present in North Africa. And then, if we go on to this side of the map, we have the Amazon rainforest right here in Brazil. And you might be saying, well, how are they affected by the Hadley cell? Well, let me tell you. Basically, the Hadley cell causes a lot of precipitation around this area because it warms this side, causing a lot of air, hot air to rise and moisture to rise, and then it dumps it all here. So that leads to this part not having a lot of water, and this part having a lot of water, aka precipitation. Now that's all fine and dandy, but there's one thing we have overlooked up to this point. The Earth is tilted at about a 23.5 degree angle. Now this does have some repercussions on our convection cells and the Earth as a whole. So what happens as a result of this tilt is the solar radiation is unequally dispersed across the atmosphere, because imagine the sun is right here and the Earth is tilted. It's going to hit more solar radiation on this part than this part of the Earth. So that leads to unequal weather patterns and wind patterns due to this unequal solar energy distribution. And it also leads to warmer waters in these tropical areas because they are, of course, closer to the sun. We've been yapping a lot about these Hadley cells. And because of that, we've been neglecting the feral cells and polar cells. How sad. Let's give them a little bit of attention. So, what the polar and feral cells do is they regulate cold air near the poles, north and south. And they take this cold air and they move it down towards the equator or move it up towards the equator. And this causes precipitation and low temperatures as it moves this cold air.
Now, what do we say to our APES viewers?
Like and subscribe.